All right, ladies and gents, I have two problems here. The first one is asking me to find angle A. So before we start, a little quick rehash. If I have an angle inside a circle, if that angle is a central angle, let's just say this is 70, then the arc measure that this guy covers is going to be the same amount of degrees as the angle itself. However, if this angle is an inscribed angle, right? Let's just say this is 40, then we know that this arc measure has to be 80. So a central angle is equal to, not a very good drawing, a central angle is equal to the arc measure, and an inscribed angle is only half of the arc measure. So let's keep that in mind when we go to do this one. This guy is an inscribed angle, and he's covering 80 degrees of arc measure. Since this number, right, creates an arc measure that's double him, he only needs to be half of 80, so we know that this is 40 degrees. Hope that helps. Now, we have a similar issue here where they're looking for arc measure VW, and I also am asking for what is the angle of V over here. So over here, since this is 42 degrees and this is an inscribed angle, remember, inscribed angles command double the arc measure. So if this is 42, 42 times 2, I know is 84. So I know that this guy has to be 84. Now I want to know what is angle V. Well, angle V is this angle, and there are a couple ways to get it, right? Hey, if this is 84, this is the center of the circle. XV goes through the center, which means XV is the diameter. Since XV is the diameter, that means this has to be a 180 degree arc measure. It's covering half the circle. Since this is 180 degrees, 84 of that is here. This has to be the remaining 96, or 180 minus 84 is 96. So I know that this has to be 96 degrees. Make sense? Hope so. So 84 here, 96 here, all together you've got your 180. Well, let's take a look now at angle V. Angle V opens up to WX. If WX is 96, then that means this guy has to be half of 96, because inscribed angles are going to create double the degrees in arc measure. So this is half of 96. We know this guy is 48. We're not done yet. That was one way to do it, right? Well, I know this is 84. I know this is 96, but in all honesty, you don't need none of that, because let's check this out. This is the diameter, which means XV is 180 degrees. If this is 180 degrees, let's take a look at angle W. Doesn't angle W go to XV? Angle W is commanding 180 degrees that way. If this is 180 degrees, then that means angle W has to be half of 180. Hey, angle, that's 90 degrees. I know that's 90 degrees. Wait a minute. This is a triangle. All the angles in a triangle add up to 180. Well, 90 plus 42, I know is what? 132? So how many degrees do I have to add to 132 to get 180? This has to be 48. Get it? This is a right triangle. If this is 90 degrees, these two angles are the other 90 degrees. So I could say 90 minus 42, or I could add these two up and say 180 minus 132. What's left over here is 48. Anyway, hope that helps.
Yep.
Okay, forgot to mention, let's just take any circle, and I'm going to create a diameter, right? I'll call this A, I'll call this B, and the center is right there. So I know that arc measure AB is 180 degrees. Anytime you have a diameter, you're always going to have that. So now I'm going to pick any point here, like right there. And let me go to A, and let me go to B. Well, look, and I'll call this C. Doesn't angle C cover arc measure AB? So doesn't angle C have to be half of 180, which is 90? Angle C is 90. It doesn't matter where point C is. Let me do it over here instead. Put C over here. I go to A, I go to B. Hey, that's going to be 90. As a matter of fact, no matter where I put point C, if I connect it to A and B, I am always going to create a right triangle, because this will always be 90 degrees. Because AB, arc measure AB, is 180 degrees, no matter where I put the point, right? As long as I connect C to AB, I'm going to create a triangle, and it's going to always be a 90-degree right triangle. So, hey, let me put the point way over there. I go here, and I go here. It's a right triangle, 90 degrees, right? I could do it up top, and green. I go over here, connect A, connect B. That's a right angle. It is impossible to take a point. Hey, what about here? I take a point over here, connect to A, connect to B. I've created a 90-degree right triangle, which means you could use Pythagorean theorem, right, on this, and that. This is always going to be the hypotenuse to a 90-degree right triangle anytime you have an inscribed angle that connects like that. Hope that helps.